Hi, everybody. This is probability video number 11, and we are still talking about the formula, the OR formula. We did an introductory video. That was number 10. Maybe you just finished watching it. It was basically like, how do you tell the difference between things that are mutually exclusive and not mutually exclusive? And I hope I clarified so that you can remember the difference. And this is specifically about dice, and because honestly, it's not that interesting to watch me write out the sample space. I already did it. So again, this represents a 1 on dice 1 and a 1 on dice 2. This one's a roll 2 on dice number 1 and a roll 3. So by doing out our sample space, you know you're not going to miss anything. I suggest pretty much any question, especially in a test situation, you are better off if you can to draw out your sample space than just than not drawing it out and just kind of guessing and trying to make sure you don't miss any options. That's the biggest thing for me. I know if I do this, I'm not going to miss any of my choices. All right, draw out the sample space. Boom. Oh, I guess I could have put the sums in there instead of putting the numbers. Oops, it's okay. I and you can tool that up pretty easily. Rolling a sum of 7. So I'm going to end up making a really messy chart. 2, 3. Okay, so there's 1, 2, 3, 4, 5, 6 ways to do it. 6 out of 36, which gives me 1 out of 6. And oh, I gave my calculator away. So this should work. One divided by 6. So 0.17. Yeah, usually we've rounded to 2 decimal places. All right, rolling doubles. 1, 2, 3, 4, 5, 6. That's also 6 out of 36 is equal to 1 out of 6, 0.1. You don't need this step. That's habits, reducing fractions. Okay. Now we got to watch. It says OR. So I'm going to use a formula. And sorry, I'm going to use my sample space because it's easier. And then I'll also show you what it looks like with the formula. So 7 are doubles. So they are both good. So all I need to count is all the ones I circled in pen and all the ones I circled in green ink. I don't know how well you can see that. And my sample space is still 36 because there's 36 little boxes in there. And that should be 12. So that's going to be 1/3, which is going to be 0.3 repeating. If I wanted to do that as a formula, the probability, let's go call this S. We'll call this D. I don't have to write. So we got sum of 7 or doubles is equal to the probability of 7 plus the probability of doubles. Now, I already know by looking at these, they're mutually exclusive. You can't, there's nothing that has a double circle on it. If I wasn't sure, I could put the subtract on there, but this is the correct formula when they are mutually exclusive. So the probability of 7s or doubles. So the probability of 7 we just did here. I'm just trying to figure out which one I want to do. I'm going to do it like I normally would. There's 6 of them, plus rolling doubles, 6 out of 36 is equal to 12 out of 36, which we already have. It's right there. So formula, yep. Counting my sample space, yep. Don't care, either way is good. Make sure you're showing me the work, right? The minimum I want to see is 12 out of 36. The only advantage to this is I can see your work, and if you mess this up but you show me your work, I can give you some extra marks. Okay, rolling a sum of 7 and doubles at the same time. So if I look again at my list, nothing. So that's going to be 0 out of 36. There's nothing in here that's circled twice. I was going to show you the big old formula, but why? All it would be if I wanted to write it, oh, you know what? I could write this as a probability of 7 equals probability, oopsies, probability of doubles equals squishy. This would be the probability of 7. Now watch it, and doubles. Remember the difference. The intersection is and. They have to happen at the same time. There has to be an overlap. And in this example, there isn't. So we're good. So it's going to be 0. All right. Next one. According to the rules of a game, a player wins 100 extra points if she rolls a sum greater than 8 or a multiple of 5. Okay. Sorry. I'm going to put the word sum in there. I'll fix all these when we go through them. Determine the probability of winning an extra 100. Hold on. I'll be right back. I'm going to go find me some highlighters. Alrighty, I'm back. So with probability and anything with sample space, I am a big fan of highlighters, and I'm a very visual learner, and I just don't feel like copying this up again. Again, if my job depended on me getting something right on a test, I don't know why my boss would suddenly give me a test on probability, but if she did, I might even rewrite it if I had lots of time, just so I could see exactly what was going on. Anyway, let's see. We need to find a sum greater than 8. Now we got to be careful when it says greater than 8. That means 8's not good enough. So there's a sum of 12. And what's cool, if you draw this out, there's my sum of 11, is they kind of go in a pattern. There's 10, and there's 9. Now it said greater than 8, so I'm done. And in fact, I'm going to do that. Okay. I'm going to get me another marker. We want the sums that are multiples of 5. So we got 4 and 1, that adds up to 5, and that's multiple of 5. It's that one, this one. See what I mean? That's the nice part about drawing the chart, is you're not as likely to miss something because they go in chunks or they go in circles, something like that. Oh, not in circles. They go in rows maybe. But 10 is also a multiple of 5. So these ones here also count. So I hope already you noticed the difference, and you probably did before I even did all my pretty little coloring, is that the first one that we did here, there was no overlap. They were mutually exclusive. Whereas here, it's not mutually exclusive. All right, so the question says, determine the probability of winning the extra 100 points using a sample space. So that's easy. I got 36, and I just count anything I just colored, and it doesn't matter whether it's yellow, orange, or yellow and orange. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 36, so it's going to give me 7 out of 18. All right, dividing both by 2. 7 divided by 18, it's going to be some weird repeating number. 0. Yeah. All right, so now if we use a formula, we're going to use it because we need to practice. But truthfully, for this one, I don't know that I'd ever use the formula. If I have this drawn out, why use a formula? The only time I think I would use a formula is if I had really big numbers and I couldn't draw out my sample space, then I think it would make more sense. But practice. So the probability, let's go E for 8. Oh, I was gonna, there we go. 8 or, sorry, had brain fight. Can you remember what 5 started with? Is equal to the probability of 8s plus the probability of 5s minus the probability of 8s and 5s. So again, this one, it makes sense. If I wanted to, I'm just going to go back here. I could have thrown on here probability of S, what was it, 7s and doubles. But then I just would have had like a -0 at the end. I'm sure you can't see that. Oh, maybe you can see that. So if you don't know, put it on there and then you can always double check. So the probability of rolling an 8, sorry, greater than 8, that was the orange. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus multiples of 5, that's what's yellow, 1, 2, 3, 4, 5, 6, 7. Minus the ones that were both colors, which was basically 10. So 1, 2, 3. And I'm just going to leave that denominator. Whoopsies, sorry, I moved that out for you. The denominator of 36 and do my math, and then I can reduce it later. So 10 and 7 is 17. Minus 3 is going to give me 14 out of 36, which it's over there, 0.39. Oh, let's look at number 3 there. What are the odds? Okay, hope your brain just went ding, 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 ding. Because we're looking at odds, not probability. But to get probability, to get the odds, you need the probability first anyway. Rolling a sum of 5 or a sum that is an even number. Oh, I'm sorry. I was just overthinking it. Because I make up the questions without the answer key, and then it's like sometimes I run into trouble. Let's just do it. Sum of 5. So probability, I'm going to put F. Oh, I already know that. No, I don't. Here we go. Let's look at the chart. But it's there already for us. So we got 1, 2, 3, 4. We're not going to count the yellow ones down here this time. We just want a sum of 5. So that's 4 out of 36. And now we want the probability of even numbers. And that we haven't done. We want a sum that's an even number. There's going to be a lot. So 1 plus 1 is 2. That's 3. There's 4. That's 6. And then it's probably going to be, here we go, 4, 2, and 6. You guys seeing the pattern? Because I am. And I suspect some of you predicted before I even started doing this. Probably going to be about half of them. Which makes complete sense. So that should be $18 out of 36. Now we want odds in favor. So that means it's the probability of what I want. So the probability of 5, make it easier. What's the word we used? So basically it's 4. I can't remember the word, so I can't write 4 to 18. So when it's in favor, you put your event. There we go. First, and then after. And if I reduce that down, I can divide both those by 2, and that is going to give me 2 out of 9. So probably shouldn't have thrown that odds question in there other than a really good review because it doesn't use the formulas. So have a spectacular day, and I hope these videos are helping you because I want to see success. Whoops, I don't know what I just did.